Good afternoon. Welcome to the first annual Graylog Go. My name is Jim Nitterauer. My talk today is called Addressing the Cluster that is AD DNS Logging using Graylog and a custom plugin. I'm a senior security engineer at Zix and AppRiver. Before we get started, I want to thank Leonard and Justine and the rest of the crew at Graylog for inviting me to give this talk today. So let's get started. First, before we get started, information disclosed in this presentation is intended to help improve your security and privacy posture and should not be used for unethical purposes. The concepts presented are in no way meant to imply original research on my part or on the part of my employer. The information presented here is gathered from public and private sources with proper references and credit where provided and applicable. And the views expressed in this talk are not necessarily the views of my employer. So let's get started. Who am I? My name's Jim. I've been working in the IT and internet business for more than 25 years. My master's degree is in microbiology and I have a bachelor's degree in biology. I started a company back in the 90s called Creative Data Concepts, a web hosting company based out of Pensacola, Florida. I've worked for Grid South Networks. I've worked for AppRiver and now for Zix Corporation. I've been heavily involved in the InfoSec community. I'm a senior staff member at B-Sides Las Vegas. And I've spoken at quite a number of InfoSec conferences on a variety of topics around the country. I have a CISSP and a CISM, and I'm currently a senior security engineer at Zix AppRiver. So let's make DNS great again. I promise that I'll make DNS great again. Let's first look at our agenda. We're going to do a quick DNS review. We're going to do an overview of AD DNS and DNS query logging, or otherwise known as DNS debug logging. We're going to look at some of the problems with that current logging. We're going to look at why DNS logs matter. We're going to demystify some of that cluster, looking at some AD DNS logging tricks, shipping that data to Graylog, and using a custom plugin that was written in Java. We're going to look at the results. We're going to look at some practical uses and have a wrap up. Today's talk is going to go pretty quickly because we only have 25 minutes, but in any case, you'll get my contact information. You'll be able to hit me up later on. So why this talk? Our external DNS filter would alert us when we saw malicious domain queries originating from our network. We wanted to rapidly correlate those indicators of compromise with attribution to the source IP of the DNS requests that were happening internally. Our Microsoft AD DNS debug log format is difficult to work with. We turned that on, we could see where the queries were coming from, but we couldn't correlate the two together in the same interface. We were already logging the external DNS queries on our Graylog instance, so we wanted to figure out a way to ship the logs from the internal network, put them into Graylog, and then compare the two so that we could attribute the DNS queries back to a particular machine within the Active Directory. So we built a custom solution using Graylog plugin and Graylog cluster. Before we get started, let's refresh ourselves on how a DNS query works. Imagine a local host or a machine or a domain joined machine on the network sends a query to a DNS server. Typically in an AD environment, that's going to be your Active Directory DNS server, one or more of those, hopefully more than one. That server serves as both an authoritative and a caching server. Anything that's local, it will serve authoritative answers for and provide that data directly back to the local host or the machine that's connecting and asking the question. If that server does not have that information, it will either forward it to the root and work its way back, or it will send it to an upstream caching server. So the way queries work when they leave your network, first it goes to the root server to see what top-level domain servers are authoritative for that top-level domain, for example, .com, .net, .org, etc. Then, based on the second part of the domain name, let's say it's appriver.com, the second part of that domain name would be AppRiver. Now we know that within that top-level server, there is a authoritative server for appriver.com, one or more of them. The top-level server returns the authoritative server to the cache server. This cache server then goes and asks one of the authoritative servers and then gets the answer that way. So an overview of Microsoft AD DNS. Microsoft AD, or Active Directory DNS, is authoritative for local DNS, like we said, and it performs recursion on behalf of connected clients. So it forwards all of those queries to somewhere on the outside. Either the default would be to send them to the root servers, or secondarily, you can create forwarders that will forward specific queries or all queries to some known outside DNS server like Cloudflare or Quad9, something like that. All devices in an Active Directory should be configured to use your AD-DNS servers. Some DNS debug settings can be configured via the GUI. The rest must be configured using these following PowerShell commands. The get-DNS server diagnostics shows you the current settings of the DNS server for how it's logging, and you can set those flags back and forth with the set-DNS server diagnostics, and I'll give you the specific commands for that in just a second. So here's what you get when you turn on default debug logging within Active Directory DNS server. The first part of the log file that's created looks like this. It shows you all of the fields that are included within the data lines that come out as your logs. So what you'll see in those logs is exactly what you're seeing here. So you'll see this information. Now, here's what you really get. Here's each individual log line that you'll see. And this is 4 log lines that constitute one DNS request from 172.16.1.41. It's asking for roaming.officeapps.live.com. That packet was then sent out to 9.9.9.11, which is the forwarding server that happens to be configured on this Active Directory controller. It receives the data back. As you can see, there's a send, then there's a receive back from 9.9.9.11, gives you the answer, which was an A record in this case, and then it's sent back to the client to the 172.16.1.41. The problem is in these records, the data is not tab delimited, it's space delimited, and the field lengths vary across those. So that's one of the problems. And the other problem is obviously the formatting of the domain name, which is the most useful part of the information here, is what we correlate all of our data off of. So let's go ahead and look at what's the impact here if we can't read this data. Well, when something's going wrong, right, when you really, really need the information, when you're in the middle of an event, when you're in the middle of an incident response, you need the data, but it's not there. So I don't always read the event log, but when I do need it, I can't read it, right? So it's like it's there, but what the hell good is it if I can't look at it? So why do these DNS logs matter? And then we're going to get back to how we're going to solve this problem. DNS is one of the top 3 indicators of compromise. And I say that if you ask any SOC analyst, they're going to tell you that if they could have 3 things from your network reconnaissance or your logs or your critical history data, one of those 3 is always going to be outbound DNS requests, because that's going to be the first indicator of compromise on your network, either for botnet command and control, ransomware, those sorts of things that are going to be indicators of compromise. The DNS logs are critical for the rapid identification and containment of compromised devices. And you can also use these DNS logs to figure out if you've got misconfigured DNS, where you're leaking what should be internal or private information out to the public internet and public DNS. Microsoft AD-DNS is ubiquitous, and the DNS debug log format, as we saw, is difficult to work with. So this is where we stand with getting onto the next level. So what can we learn from some of this, right? So let's look at some practical examples. Some of the things that we found looking at DNS logging. Now, this is looking at logging on a public interface side. This is the reason we wanted to find the attribution to the private side. We're able to find things like DNS data exfiltration. This is an example of a particular customer, one of thousands of customers that we had that were using our DNS service. We were able to see very clearly that the domain here, www.ps780.com, with that subdomain, was using DNS on a routine basis. And within that data, there were text records, and it was actually exfiltrating data. And here's how that's done. Within a DNS text record, there's a chunked payload that's usually encrypted by some sort of encryption format that the malicious actor puts within the network. That data goes out to, in a text record, the receiving domain, the receiving authoritative server then takes that chunked payload and reaggregates it back on the malicious side, giving the malicious actor the files in a chunk by chunk basis. So it's exfiltrating DNS via or it's exfiltrating data via DNS. Same thing could also be done for botnet command and control. Inside that chunk payload could be commands back and forth between the DNS server and the botnet software that happens to be running on the compromised machine. So DNS exploits that you can also catch with logging your DNS would be something called domain generation algorithm domains. This is what the malicious actors use to generate background noise within your DNS so that they can obfuscate the DNS that's used to do the botnet command and control. So they'll use something called a domain generation algorithm, create a whole bunch of background noise, which will obfuscate any legitimate from the malicious actors' point of view, DNS requests heading out of your network. These are some examples of ones that we've caught on various customers' networks. In this case, the malicious actor did not create a fully qualified domain name, so the data was not getting out to the internet off to an authoritative server. But you can see that they're kind of all over the map. But the percentage is pretty consistent. So it raises or elevates the floor of background noise so that it obfuscates any other domains within that same root domain that would be sent out over the DNS request. So it makes it harder to catch what's really happening. There's also data feeds that you can get where those feeds have aggregated domains that are used for crypto mining, domains that are used for ransomware, domains that are used for botnet command and control. And these become very useful as feeds that you can integrate directly into your Graylog instance and then use those domains to compare against domains that you find within your public interface DNS logging or the Active Directory DNS logging that I'm going to show you how to configure. And you can actually then go and pinpoint which machines on your network might be compromised via simply looking at your DNS and comparing it to these data feeds. Another exploit that you can sometimes catch in DNS is something called DNS amplification, where an attacker sends a large number of DNS requests to a variety of open resolvers across the internet, sends that as a small packet. That packet then gets replied to and sent back to the source IP. The problem is these are UDP packets. The attacker spoofs the source IP, makes the source IP the IP address of the victim that they intend to DDoS, and then all of the data, all of the packets get sent back to that victim. So it's DNS amplification, which creates a DDoS attack for that victim. So let's get back to demystifying this cluster that is the way that Microsoft DNS debug logs are stored. So the way that we solve this is there's some key components. I'm assuming here that you have a working Graylog cluster, at least one or more machines with your Elasticsearch either on the same machine or on a separate Elasticsearch cluster. You're going to need a Java plugin that's been custom written by me that I can provide you if you're interested in implementing this in your network or on a machine that you want to test. You'll need an AD DNS server with DNS debug logging configured. And it requires a couple PowerShell tricks that I'll show you here in a second. And then you'll need nxlog installed on that DNS server. So nxlog collects and ships logs in the correct format. And it rotates these logs based on some parameters that we'll put in the configuration file. So here's the steps on how to get this to happen. First, we'll look at the AD DNS server. First step is to create a folder on your machine somewhere. I put it in the C drive, you can put it in the D drive, it doesn't matter where you put it. Create a folder to put these DNS debug logs in. And what you're going to do is you're going to go in and take that path and then add a file name to it in here in the next step. We're going to use the DNS GUI in Windows to configure and enable a DNS debug logging basics. And that's what you're seeing in this image over here on the right. That's the settings you need to set. The file path and the log names you could put to be whatever you want. The thing I will say is this maximum size by default is 500 megabytes. I would reduce that to 50 megabytes per file. Save that and restart your DNS server. And then what you'll do is you'll open up a PowerShell command prompt as an administrator on that machine, and you'll run these first two commands. The first one is set DNS server diagnostics -, right through /1. That allows multiple executables to read the log files, the debug log files while they're in operation so that they're not contentious for the file. The next one is to set the DNS server diagnostics, which is enable log file rollover, and that forces the Active Directory DNS server to roll those logs over when they hit that 50 megabyte limit. If you don't do that, the DNS server will then take that log, erase that log, and start the same log file name with back to 0 with nothing in it. So you'll lose all your data history as soon as you hit that 50 meg or 500 meg or whatever that value is set at. And you can validate these settings with the get-DNS server diagnostics function within your PowerShell command there. So the next step would be to install NXLog. NXLog comes as both a community edition and a paid edition. In my case, I use the community edition. You basically install it on your ADDNS servers, all of them. You put the same config in there. You might tweak the config so that your ADDNS server names that are in here are unique to the machine that's sending the query, so you know the source of the queries, right? So if you have 3 or 4 hosts in your ADDNS infrastructure, each one of these would be unique for the host that it's installed on. But what this does basically is it turns on this Gelf Graylog extended log format module that's built into NXLog. It turns on the file operations module. This file operations module is what it's going to do. It's going to every 10 minutes go through and remove files that are older than the date of now, right? The timestamp now minus this many seconds. And I think that's 30 days. I don't recall off the top of my head what it is, but it looks like it's about 30 days. So we keep about 30 days of rolling logs on the machine in that folder there. And then what we do is we take that we point it to where the folder is, where those log files are. We do a little bit of trickery here. We tell it we add a host name field. We add a couple of parameters here that get sent along. And then this is important here. We tag the source name as ADDNS log and do that across all of your machines the same way. And what that'll do is it'll allow us to search very quickly for this source name when we're using Graylog. And then we create the output, which is a UDP output that's connected to this port here, 12253, which would be the same as the input port on your Graylog cluster. And we're using the output type as Gelf Graylog extended log format. And you'll see why that's important once we get to the next step. Then we tell the router within NXLogs, hey, take this thing that's in my input and send it to that output. So now you got this input here going to that output there, and we're ready to go to the Graylog cluster and get that configured. So what we have to do on the Graylog servers, if you have 1 or more, each Graylog server is going to need this Java plugin dropped into the plugins folder on the machine. So everyone will need a copy of that jar file. And then you'll have to restart the Graylog service on each of those cluster members on every machine that you add this plugin to. Then you can configure the input. We're going to create a stream on that input. We're going to create an index for the input. And then we are going to enjoy the ability to look at our ADDNS debug logs in a format that humans can read and understand. So let me show you a little bit more detail on how that works. So here's the steps again. First, we create the input, and you can start by just creating the input up here. At the top, there's a create input, and these are the parameters that you need. But the most important part is you pick the bind address, and then you bind it to the same port that your NXLog is shipping to. Next, we create a stream based on the input that we've created, so that we now are tagging everything that's on that input to be in this stream. And then the next thing we do is we create an index within our Elasticsearch cluster based on that particular input as well, or that particular stream, right? So what this does is it speeds up the queries and allows us to search just the records that we want to search without having to separate them from some aggregated block of Elasticsearch data that's bigger than what we really want to be looking at. So those are the steps that are involved. And here's the results that you get. This is what really is bottom line that you want here. If you look at these fields here, if you were to scroll down, I can't show them all on the screen at one time, but they would show you all of the fields that were in the top of the first few lines of the ADDNS debug log that lived on the AD server. In this case, I've obfuscated a couple of things, but I did add 2 fields here. I added, is this an abuse domain, and is the source IP an abuse IP? Those are added to this stream by matching the input or the IP address to against some lists and then putting that data in there. So again, remember I told you could add ransomware DNS lists, malware DNS lists, all of those things could be added to Graylog by default, and then you could match the source IP against any one of those lists. It would create a separate field here in this add-on, and you would be able to see what you needed to see there. So that gives you the information. all of the fields would be over here. You can click this and you'll see the fields pop up in the typical Graylog behavior. If you were to look into your settings and your system settings, you would see that there was a custom Java plugin for that input, and it would show up in your system. But this is really the bottom line use. You want to be able to create useful dashboards. You want to be able to create alerts on streams. You want to do the things that are going to help you understand what's going on in your environment. And real quickly here, this first graph shows query responses over time. Down here are the types, right? So most of them are no errors. But it shows here in this case that 10.3% of all the domains are NX domains. So then you can go back to your raw data and you can look and filter for all of the ones that are NX domains and see what's going on with those domains. Are they domains that shouldn't be looked up? Are they malformed? Are they things that shouldn't be leaving your network? All of that sort of thing can be analyzed from this. You can look at the query types that are going out, in particular text records, pointer records, quad A, any records, all of that sort of thing. In this case, you can see that there's 1, 2, 3, 4, 5 different domain controllers reporting in here, and it shows you the percentage of queries coming from those. This shows you, I can't see what that one is. I don't see the title on that one, so I don't recall what that one is. This gives you an hour's worth of all the queries from all the controllers. Down here, you can see the responses, right? So there's no errors in X domains. So that's a numeric depiction of what's here. These are the top domain names that are being looked up. These are the top query record types. So you got A's, quad A's, and you're going to see quad A records continue to proliferate, right? If you don't have IPv6, they're still preferred, they're still used, and it's still happening on your network. And then over here is the number of queries per domain controller, which is basically what we saw in this graph here. But there's so much more information that you could put in here. I don't have time in this talk to go over all of it, but I do appreciate your time. If you need to get in touch with me, my number is, or my email address is there. I'm on Twitter. There's my handle, Nitterauer, and you can look me up in at LinkedIn. So I appreciate your time. Enjoy the rest of Graylog Go and hit me up if you have any questions. Thanks. Bye-bye.